Alright, so the last video of this unit is on the trig form of a complex number and some operations with complex numbers. So in the complex plane, the complex number a plus bi is related to the component form of the vector ai plus bj. So we have this vector a with the I vector plus b, which is your j vector. This is on the I-axis and the real axis. So this is your real part, this is your imaginary part. So you want to find the trig form of this complex number. So the trig form is going to be the modulus. So z equals a plus bi is the same. We have this point here, which is z. The same as saying r times the quantity cosine theta plus I sine theta. So this is very similar to how we found our vectors before with cosine theta and sine theta. You can multiply through if it makes it easier to see for you, r cosine theta plus I r sine theta. So here our a value here is r cosine theta, our b value is r sine theta, and then we know r is still our modulus, a squared plus b squared, and take the square root, and our theta is still this y component over this x component. So something to keep in mind is r is the absolute value or the modulus of z. So the absolute value or the modulus of this, which is what we know as our magnitude. So you can think of this the same as our other vectors. Theta is the argument of z, and that's just saying that this is the angle that you're associating this with. So we want to write 1 minus 3i in trig form where theta is between 0 and 2 pi. You want to make sure you're keeping track of that your angle is in the right quadrant. So to do this, first we got to figure out our parts. So we know a equals 1 and b equals the negative square root of 3. This comes straight from here. This is a, this part is your b. So now our modulus, or r, is going to be the square root of 1 squared plus negative square root of 3 squared. And that's going to give us square root of 1 plus 3, which is square root of 4, which equals 2. Now we got to find, so we have our r, and we need to find theta. So theta, we can use tangent inverse of b, which is our negative square root of 3, over our a, which is 1. And that's going to give us negative 1.04. But we have to, so this is in radians. Okay. So now we got to make sure we're in the right quadrant. So we went over 1 and then down negative square root of 3. Okay? So we're in the right quadrant, but this angle is not within our restrictions. So although the quadrant is right, we're going to have to add 2 pi to get it within our restriction. So if I add 2 pi, I now have 5.236. So to write this in trig form, I'm going to have my r, which was 2, times the cosine of 5.236 plus I sine 5.236. And that'll be trig form of 1 minus square root of 3i. Okay? So let's try another example. We want to write negative 3 minus 4i in trig form, and now we're looking at degrees. So this one, our a is negative 3. Our b is negative 4. So r is the square root of negative 3 squared plus negative 4 squared. And that's going to give us 5. Now our angle, we take tangent inverse of -4 over -3. We're going to make sure we're in degree mode. And we're going to have 53.130 degrees. Okay, so we're going to check it. So we have -3, -4. 53 degrees is up here, so we're in the wrong quadrant. So we have to add 180 degrees to get into the right quadrant. So that's going to give us an angle of 233.130 degrees. So this is our angle. Okay? So to put that in trig form, we're going to have our R value, which is 5, times the cosine of the angle we found, plus I sine of the angle. Alright, that's a parenthesis. So this is trig form of this angle. So now that we know trig form, it's going to be a lot easier to do some of our other operations with these. So let's look at multiplication and division. So for multiplication and division of complex numbers, we're going to have two complex numbers, z1 and z2, which are both in trig form. So z1 is r times cosine theta plus I sine theta, and z2 is r2 cosine theta 2 plus I sine theta 2. Okay, so this is just general trig form of two different complex numbers. So now if I want to multiply them together, I want to take z1 multiplied by z2. I'm going to take their magnitudes, r1 times r2, all together multiplied by cosine of the sum of the angles plus I times the sine of the sum of the angles. Okay? Important formula to memorize. We will actually work on deriving this in class to see where it comes from. To divide them, z1 divided by z2, you're going to take r1 over r2, and you'll be multiplying this by the cosine of the difference of the angles plus I sine of the difference of the angles. And here, r2 cannot equal 0 because you cannot divide by 0. Again, this one too, we will also derive in class to kind of see where it comes from and how it works. So let's try some practice problems. So first we want to find the product of these two numbers. I have z1 is 25 square root of 2 cosine of negative pi over 4 plus I sine of negative pi over 4. And I have z2 equals 14 times cosine of pi over 3 I sine of pi over 3. So to multiply them, I have z1 times z2. And that's going to equal my r1 times my r2. So I'm going to take 25 square root of 2 times 14, and all of this is times the cosine of the sum of the angles. So I have negative pi over 4 plus pi over 3 plus I sine, and again of the sum of the angles. So now to simplify this a little bit more, 14 times 25 is 350. So 350 square root of 2. Now the negative pi over 4 plus pi over 3 is the same as pi over 12. So I have cosine of pi over 12 plus I sine of pi over 12. So this here, we'll do it in green, is trig form. Okay? Now if I put this in my calculator, cosine of pi over 12 times 350 square root of 2, I'll get 478.109 plus 128.109i. So again, this is just evaluating cosine of pi over 12 multiplying by 350 square root of 2, evaluating sine of pi over 12 multiplying by 350 square root of 2. This here is decimal form. So it's important to note the difference between the two forms. Okay? So now let's try another example. So this one was multiplication. Now I want to try division. So if I want to do z1 divided by z2. Okay, so I have two different ones here. I have 2 square root of 2 cosine of 135 plus I sine of 135. And then I have 6 cosine of 300 degrees plus I sine of 300 degrees. So to divide them, I take my r values. So I have 2 square root of 2, so that's z1, divided by the r of z2. Then I'm going to multiply by cosine, and then I'm going to subtract the angle. So I have top minus bottom. So I have 135 degrees minus 300 degrees, plus I sine of 135 degrees minus 300 degrees. So that's going to give me 2 square root of 2 over 6 times, now I subtract these, I'll have the cosine of negative 165 degrees plus I sine negative 165 degrees. And I can simplify this first part too, so I'll get square root of 2 over 3 times cosine negative 165 degrees plus I sine negative 165 degrees. So this here is trig form. And again, I can multiply this out. So take the cosine of negative 165 and multiply by square root of 2 over 3. And I'll get negative 0.455 minus 0.122i. And this here is decimal form. Okay? So make sure that you can put these in your calculators, get both the trig form and decimal form. So the last thing we're going to talk about here is the powers of complex numbers. So I want to let z equal r times cosine theta plus I sine theta, and let n be a positive integer. So if I take z and I raise it to the power of n, it's the same as r, so it's the same as my z raised to the n. The way DeMoivre's theorem works is it says that I can do r raised to the n cosine of n theta plus I sine n theta. Okay? So for these problems, right now I have it in standard form. So I need to change from standard form to trig form. So to change to trig form, just like we did before, a equals 1, b equals square root of 3, r equals the square root of 1 squared plus square root of 3 squared, so r equals 2. The tangent inverse is b over a equals 60 degrees. So now I'm ready to use DeMoivre's theorem. So right now I have z equals my r, 2 times cosine of 60 degrees plus I sine of 60 degrees. Okay? So that's just this part right here. 1 plus I squared root of 3 equals this. So now I want to cube it. Z cubed equals, now using DeMoivre's theorem, I can do 2 cubed cosine of 3 times 60 degrees plus I sine 3 times 60 degrees. So that's going to give me 8 times the cosine of 180 plus I sine of 180 degrees. So that gives me 8. The cosine of 180 is negative 1. And the sine of 180 is 0. So now I have negative 8 as my answer. Okay? You can also check this by multiplying this together 3 times, but that gets tedious. It gets especially tedious when you have higher powers. So this one, you really would not want to multiply these out. So the power of 8. Okay? So for this one, we're going to again convert to trig form. So we have A equals negative square root of 2 over 2. B equals square root of 2 over 2. So to find my R is the square root of my A squared plus my B squared. When I multiply this out, I get R equals 1. Then I take my tangent inverse to find the angle. Which is negative 45 degrees. But again, this point here is in this quadrant. Negative 45 degrees is here, so we have to add 180. So my angle is 135 degrees. So now I'm ready to use DeMoivre's theorem. I have my complex number is R, which is 1, times the cosine of 135 degrees plus I sine of 135 degrees. So DeMoivre's theorem, it says z to the 8th equals 1 to the 8th, which is still 1, cosine of 8 times 135 degrees plus I sine of 8 times 135 degrees. Multiply this out. I'll get 1 plus 0i. So z to the 8th equals 1. Okay? So they will not all necessarily work out to be this pretty, but it's a good start to make sure your angle is in the right quadrant and you're using the formulas appropriately. So that is it for this lesson.